I don't know if it's working now. Please reply in the chat if it is working or not, so I could start. Okay, I hope the quality is good because I have no microphone right now. I'm just using the computer's microphone. Anyways, sorry for the internet cut, usual problem. Yeah, so I think I could start right now. Before talking about binary exploitation, I would like to thank the people who donated for the past live streams. Again, thank you so much for donating and for encouraging me to keep up with the good work. Okay, if you want to help me also, this is the platform from where to donate on. Okay, and what else? Yeah, I think we could start right now. Right. I'm watching. The internet cut is a big problem because I lost some views, but anyways. Okay, so binary exploitation. I'm going to talk about what is binary exploitation, about about computer architecture, and about some C programming, like low-level programming and low-level architecture. Just low-level stuff, because binary exploitation is focused on low-level stuff. So you need to have a, let's say, a basic understanding of how a computer works in order to start playing with it, start exploiting stuff, because everything is in low level. So if you don't understand how a computer works, you will struggle in playing with stuff here. Okay, so okay, just let me open the chat on my phone so I could see your messages. Okay, so if you got questions along the way, if you'd like to ask about anything, even other than binary exploitation, I would be more than happy to answer your question. So yeah, before starting, I would like to also introduce you to some websites that you might know or you might not know, which got binary exploitation challenges, and I'm going to start with the easiest one to the hardest one. So Pwnable.xyz is a website made by a team called Open2All, which is a really old CTF team. Also, it got challenges here. All of the challenges start from beginner level to some, I would say, medium. It's not really that hard. It got challenges about everything in the user land. So buffer overflows, integer overflows, some heap exploitation stuff, and everything. Also, for this series, I would like to make short live streams. I don't know if this is a good idea or not, but I think short live streams would be good, because I could just talk about one subject in this live stream, and in the next one I could talk about another subject, or even split a subject into a general point of view. So, and then in the next live I could talk about more details about it. So support me, please, lonely hacker. Okay, also guys, we made the Discord server. Let me just grab the link. Right, so this is a link. The Discord server. In the Discord server, we will have talks about security, about programming, about everything, about bug bounty, whatever. I might also throw some challenges in the Discord for you to solve, stuff like that. So I encourage you to actually join the Discord server too. All right. So this is the first website I talked about. You could take a look. We got next pwnable.kr, which got big, easy challenges, medium challenges, hard challenges. It's a good website to learn. Like, it got even some like problem solving, not only binary exploitation. Like, I remember a challenge with problem solving where you need to use some binary search to solve the challenge. So it's also a good website. Take a look at it. And the latest one is pwnable.tw, which contains the hardest challenges, and it got really high quality challenges. So this is the best. If you really want to take your skills to the next level, then you need to check this website. Okay. So also, if you got challenges or if you are stuck with a challenge and you want to ask me for help, I would be also happy to help you with it. I think we are ready to start. So I made 2 folders. I think I was thinking about 2 attacks to showcase in this. Okay, I think somebody donated. Ali Kneni. Thank you for the donation. Okay. And okay, I was talking about aren't the heap challenges very outdated? Pwnable.tw. Most of them are outdated, yes, but it's a good way to start because, like beginner level, the old heap exploitation techniques are a good start. That's what I meant. Because the modern attacks are more sophisticated, more complex scenarios. Not all of them, but yeah. Okay. So I was thinking about two attacks for this live stream. It is buffer overflow. Native. Okay. It's a buffer overflow, but I will showcase 2 techniques to exploit it. To exploit the buffer overflow, I will start with a basic technique, and then I'm gonna talk about another technique. And before even doing all of that, I'm going to write some code, write a vulnerable program, and alongside so when I will be writing the program, I will explain C syntax and low-level stuff along with it, and I will also showcase some assembly knowledge, very basic assembly knowledge. And what else would I do? I think that's it. I might also talk about some mitigations and how to bypass them, but that would be for another part, I think. So yeah, let's start with the first one. It's just a basic buffer overflow. I will Jileni, thank you for the 5 Tunisian dinars. I was thinking about actually taking the camera, setting a camera for this live stream, because why not? So okay, I hope this is better. Okay, so the C program. Let me zoom a little bit. So in every programming language, you got the libraries that you want to use. An example for Python, if you import math, you could use math functions and everything. Just the same thing in C. You got some libraries, which is basically just some code that is predefined, pre-built, that will contain some functions that are help functions for you along the way to code with them. Face reveal. توحشنيه بالوجاية. قل لي صح اليونيت على الخير. Okay. So the stdio.h library is basically the standard input-output library, which will contain input-output based functions, just like the printf function, the puts function, which will show strings to this or characters to the screen. And then this is how you declare a function in C. You put the return type. So this is the return type, which is the type the function will return. So int represents an integer. That means that the main function, after finishing execution, it will return an integer. This is actually welcome to the gang. You lose more each year. True. Okay. This is also important because in some exploitation scenarios, you'd need to know that the function returns something, even if you declare the function as void. Okay, so the void type is basically nothing. So if you declare some function with void, that means that it doesn't return anything. However, it's not true. Every function will return something after its execution, and we will see that with the debugger later. So I made it return a 0 here. I would also talk about status codes, because why did I return a 0? Why not like some other number? Basically, 0 represents it's a number that will represent that a code which says that the program executed normally, so it finished execution normally. And you could see that. So for example, if I execute an unknown command in the CMD, you'll see this number here, 127. 127 is also a status code that represents a command not found error. And if I executed a command normally, so echo 0 or echo anything, we could also echo the return code. This is how we return the return status code, and it's a 0. So we know that the command executed normally. Okay. Then I could just, I could make a puts hello world. Oops. I was programming with QWERTY and then I switched it to Azure back, so it's hard to write. Okay, and also I'm using the GCC compiler, which is the GNU C compiler, to compile the program. So this is how we compiled it. It returned an executable. The executable, we can execute it with / and then the name of it, and it will execute and show the hello world message that we got. Okay, so this is basic thing. If I try to run the file command on the buff file, it will tell me that it's an elf. Elf represents I think I forgot the abbreviation actually. It's extendable and linkable file, I think, or something, or format. I really forgot. My bad. Anyways, it's 64-bit. 64-bit represents the number of bits of the current architecture. So there are computers which hold 32 bits, and there are other computers which can hold 64 bits. And it's just a representation for how much a case in memory might hold and how much the registers might hold in size. We will talk about this in details later. And then also x86-64. This is something you would see a lot. It also represents the current architecture I'm using. x86 is basically Intel architecture. So my processor is an Intel processor or an AMD processor, and x64 will also represent the same thing. However, x86 is about 32-bit programs or architecture, and 64 is for 64-bit architecture. So it's just a different in the size of memory and the registers and everything. Also, okay, we will see this later. We'll see all of this later. Okay, I will like to talk about the steps in which we converted some source code, like just some characters, into an executable program. If I try to read the file with the cat command, you could see that there are many non-printable characters and some names and everything. So how did the compiler convert the code, the simple C code, from this part to the executable here? Basically, I will talk about this in like an abstract view of point. So first you got the source code, like in whatever language you have written in. This source code will pass through a compiler, which in this case was GCC. Then the compiler will actually output something called object file, and the object file is sometimes executable. It's basically machine code with some information, and this information here represents it represents the addresses of the library functions. For example, the address of printf in the library. It also contains information about the different sections, because the ELF file format, like the executable that we got, is actually defined in some file structure. And basically a file structure is just a way to tell the system that this is an ELF file, and like what is the size of each section, and what's the architecture that this file should run on, and like the format will just define the file for the system to execute and to interpret. And it will also contain the sections, and what I mean by sections, that there is a section for the code that would contain the compiled code. This is called the .text section. You have like a section for I would say global variables. This section, for example, will contain global variables like it's called .bss. There are actually two sections here, and most people don't differentiate between them. Actually, there are two sections for global variables, and we will see that with the decompiler later. So I'm just talking about it like in a theoretical way, but we will see it with the IDA Pro decompiler later. So actually, there are two sections for global variables. There is .bss and there is .data, and the only difference between these two sections is that basically the BSS section would contain undefined data. So like if you do int x in undefined data, I said. So if you do int x, this will be a global variable, and it was not initialized, so it will be in the BSS section. However, if you like initialize it with a value like int x and 123, for example, this will be stored inside of this section because it actually contains a value. This is the only difference, and there are other sections that I would not talk about them in this live stream, but we will talk about them in the next ones for sure. Okay, so this is what an object file is. It's just machine code with some information about the sections and information about how to put the program in memory, like in a simple way, I would say it. So this object file would pass through some other program called the linker, and the linker will just link the library calls, the library functions within the library code. So if you got a library, it will just load the library and make a connection between the functions used in our program and the definition of them in the library. And this linker will output some executable. Okay, then the executable will pass through a loader, and this loader will basically load it into memory. So you got your program loaded into the RAM and ready for execution by the processor and like to access data and everything. Now this is the basic view of point, the abstract view of how to convert from source code to some compiled program that is running on your computer. Okay, I think this is good enough. Before really talking about more stuff, I will take the program and open it in some decompiler just to show you the different sections I was talking about and everything. Okay. Excuse the virtual machine for containing so many programs. Can we pawn programs written in Python most of Pwning Riff challenges are about C and C++ or maybe Java. Actually, yes and no. It mostly depends on the functions used by the Python program. Like it will be like a more general, I would say more general exploit, because you know you are not really accessing the addresses in Python and everything. You are just accessing the general variables defined by some programmer in Python or anything. But after all, also Python is partially compiled. If you don't know about this, Python is also compiled and it runs through a stack virtual machine. So I don't know if I have ever found some Python program, but I'm sure there are challenges. I remember I think Monji has released a write-up about Python. I just need to find it. I'm trying to be quick with it. I don't think this is it. I don't think it's here. Maybe 2023. No, we were in 2023. Maybe 2022. Maybe this one. Revenge. I think. This. Oh, it's just a Python jail escape. My bad. I thought it was a Pwnable. Yeah. That's my only answer, I think. Otherwise, you'd find like a 0 day in Python itself, in the program itself. Then that would be, which is also written in a C++. So yeah. Yeah. Back to opening the program with IDA. I think I haven't copied my program. Into the virtual machine. I already got some file called buff. Okay, so this is the decompiler.
Here we go. Money talk.
Here comes the money.
Thank you so much for the huge donation. I'm so thankful for it. Thank you again. Okay, let me see if he also dropped a challenge. I'm really sorry I don't have double screen to check between the messages and everything, but I'm just gonna try to check. I hope also internet is not cut again. Mad challenge في NCNC SNE ended up bugged. I will check it. Payments. How do you access this? I actually hate the website so much. I actually hate the website so much. Okay. You can't even see the full message, but thank you so much for the huge, very huge donation. I'm really proud. I think he tried some buffer overflow into the. I have that song as my ringtone. I was so confused. I actually was confused too because it's my first time using the thing. Okay. Mad challenge in the NCNC. I think it's not the right time to check it, but it's okay. Let's just talk more about Pwn. قوثم رد بالك على الاكونت متاعك. اوكي ظهر لي انا لازم يرد بالي على الاكونت متاعي تو مش هو. Okay, so I would explain how a decompiler like IDA Pro or Ghidra or Ghidra, whatever you would call it, how could it decompile a program. So we gave it a program which is defined in. Just a second. Yeah, you see, this is gibberish. This is nonsense. It's just compiled code. It's converted from C to machine code. That's it. So how did IDA Pro recognize the C code? How did it actually, from the much garbage, how did it find out that this is the main function and this is the code inside the main function? Like the decompilation is really clear here. I have the challenge files I can send in Discord. Yeah, for sure. Yeah, send them on Discord for sure. Okay. So as I was talking, how did IDA Pro actually decompile the program? Well, it's actually a very complex process, but again, I'm just trying to give like an abstract explanation. So it's a general explanation, but it will help you understand how things work a little bit. So, so IDA basically, as I have talked before, the ELF, the executable file, contains sections, different sections. I could see the sections using a program called read-elf. You could see the help menu. I'm going to use the option called SS. Okay, S. This S is for symbols. It will show the symbols. This will show functions, right? Yeah, it will show the functions. I think object. Yeah, let me just use IDA because I love IDA more. So these are the different sections of the program. Okay, we haven't talked about all of them. We have only talked about BSS, data, and the text sections. We have only talked about these three sections. If you can't mind, can you share the source from where you got from your current IDA version? Actually, the IDA version I'm using right now, actually a friend have sent it. It's a correct version. Using correct versions in my country is legal, so it's okay. But if you want the latest version of IDA Pro, I can share a link with you. I cannot share it on YouTube though, so you could just message me on Discord if you installed it from a specific source, of course. Yes. Just send me a message on Discord or Facebook, and I will send you the link to the latest IDA Pro version. But just run it in a VM because I don't know if it's infected or anything. I'm also running this version on a virtual machine, so yeah. As I said, this will contain the compiled code. This will contain both will contain the global variables, and we have also some other sections. I'm not going to talk about all the sections, but I'm just showing you the sections. One of the sections is called. There's a Simbi section here. Yeah, it's called it's actually a table. It's a symbol table. It's called the dynamic symbols, and the dynamic symbols are basically symbols like functions and addresses that will be resolved in runtime. So it will be dynamic. We will resolve the functions dynamically during runtime. So we could just map the address of the puts function to the library in runtime while the program is running. And I'm not going to talk about it in this live stream, but I'm just giving you ideas. And you have then the symbols table, and the symbols table will contain the defined functions, like the defined functions in your current code. So you got here the main function. I think I hope you are seeing it actually. Just gonna do another zoom. Okay, this is it. This is the main function. You got the main function. You got also some other functions. Like these functions were added by the compiler, and they were added they are just helpers. And let me give like an easy example. Okay, like this one, the init. The init is basically an initializer. It's a constructor. It will help the program initialize itself, like before even executing the main function. So this function will execute, and it works like a constructor. It will construct memory. It will like initialize the different let me say like the needed functionalities basically of the program will be initialized using this constructor. And there are some other stuff that will happen too. For example, it could also execute some other constructors in a certain order. You also got the CXA finalize. This is a deconstructor. It will just like after the program finishes execution, it works like a garbage collector. It's not a garbage collector, but it will just deconstruct the program and remove like the stuff he used, the memory he used, and everything. We will actually encounter them in next live streams with more details. So yeah, I just don't want to talk about them in this current live stream because it will be like a very heavy live stream. So I'm just trying to talk about simple stuff here. And you got like the puts function, which we used, and also some other global variables and some other functions like the libc start main. This function will actually start the main function from the library. Okay, and you also got global variables like this. This contains the address of the BSS section, like where does the BSS section start exactly in memory. This is a function also. This will call the libc start main that we saw above, and it will like call the main and everything. Yeah, we will see them in more details. Just for the moment, I'm trying to give a basic overview of the ELF format and like what happens before and after compilation. That's all what I'm trying to discuss here. Okay, yeah. So now how did it decompile this into a C syntax? We said that the program contains sections, and the text section contains the compiled code. So compiled code is inside of the text section. What IDA will do is it will try from the ELF file format, because the ELF file format contains like a structure which defines where the text section starts and everything. So IDA Pro will parse the structure, and it will know where does the .text section starts, and it will just decompile. It will just decompile the code in it. So basically, let me just give you a little overview of machine code. This is how the main function looks like in machine code. So like this is machine code here. It's just bytes. Okay. An upper view of it is the assembly syntax. This is called assembly. These lines are assembly. And what assembly is? Assembly is basically, it's just a programming language, and it's a programming language that is so close to the processor. Like it's a very low level programming language. You can see all the details, like all the instructions, not all of them, but most of the instructions that the processor will execute. They are just defined here in assembly. And so it's actually a good programming language if you are trying to make like fine-grained optimizations to the code and everything. And yeah, it's just like this is machine code, this is assembly, and then this is the C programming language. So you see here, assembly is just a little bit above machine code, and C is above assembly. So it's like a higher level of view. And from assembly, it will convert it to this C-like syntax. Okay, it's not really C syntax, but it's just a C-like syntax. Is that more important to learn in Pwn first before getting into simple tasks? Like this is low-level analysis. I don't know. Yes and no. I don't know. I'm just trying. Even if you don't understand what I'm saying here, it's okay, because I'm just trying to open doors for like next live streams from this live stream. It's good to have like a good overview of how things work, of how the computer is actually doing its work. That's really important. And the only thing I'm talking about this stuff is because most of this stuff is hard to find online. Like it's hard to find resources talking about this stuff online. So I'm trying to just give it in a live stream just for everyone. If you installed it, yeah, that's an old message. Okay, so this is how the decompilation process happens. It will just take the machine code from the text section, it will convert it to assembly, and it will convert it to a C-like syntax. Okay, this is our main function. This is it. So now, actually, what's the difference between reverse engineering and binary exploitation? I feel they are pretty much the same skill. No, they aren't. I don't know. This is the table I like to answer this type of question with. So you got here reverse engineering, and you got here binary exploitation. Basically, reverse engineering, the skills you need in reverse engineering are reading code, debugging, tracing, maybe, I don't know, like programming skills. I think Rev is a sub-skill for Pwn. On the other hand, like when you Pwn, you actually reversing. Yes, this is what I was going to say. Basically, you see all these skills that you need in reverse engineering, from understanding the code, debugging, tracing, programming your own scripts and everything. All of these are gonna be used in the binary exploitation process. When you are doing binary exploitation, you are going to use all of these skills. You will reverse engineer the binary, so you are using reverse engineering. You will reverse engineer the binary. You will understand the code, but you are not just understanding the code. The objective of binary exploitation is not to just understand what the program is doing. You are looking for a bug. You are looking for some bug to exploit that program. All right. So this is the only thing that will differ from reverse engineering. You are just looking for a bug here, which you do not actually do in reverse engineering. This thing you don't do in reverse engineering. Bro, where are you from? I'm from Tunisia, North African. Okay. IE master. So I hope I have answered your question. And okay. So what am I going to show right now? I think I'm going to talk a little bit about assembly, just a little bit, because we are going to use it. He's from okay. So for debugging purposes, oh, I'm from India. Nice to meet you. Okay, I'm going to use the GDB. GDB is basically the GNU debugger. It's a Linux debugger. It's a GNU debugger, which we will use to debug the program. Also, for the new people that are watching that don't know what debugging is, let me explain it really quickly. So basically, in the process of debugging, you have that little interface where you got like the current instruction the processor is executing. You also have a look at memory, and you have registers. I will explain them in a second. So basically, debugging you will follow the code. Let's say like this is your code. These are the lines of code. In the debugging process, you will follow the code line by line. Like you will follow the execution of the code. And at each step, at each executed instruction, you could take a look at the memory, so what is happening inside of the memory, and you could take a look at the registers. Bro, can you say a little slow? Yes, for sure. So the registers. The registers are basically another type of memory. So you got the processor here. I'm just going to call it P, and okay, and I would say just under the processor, you have the registers. So they are so close to the processor that you could access them in a very fast way. You could fetch data from them in a very fast way, and you could put data into them in a very fast way. So the purpose of registers is just an optimization. It will optimize the way you store data pretty efficiently, and you fetch data in a very fast way. The only inconvenience in registers is that they cannot actually hold much of information. Can you please focus on the debugging part? That's always a tough part for me. Yes, for sure. I will try my best at explaining it. And the only inconvenience with registers is that they could only hold a limited size of information. So basically, if you are on a 64-bit architecture, the register could only hold 64 bits, so 8 bytes. It could only hold up to 8 bytes. You actually have more than one register. You do have like 15, actually more than 15. I don't remember the count, but you have so many registers. Are registers also called cache? No, not really. Actually, registers are very different from the cache. you got the registers, and also near the processor you got the cache. It's another memory, it's another type of memory, and the cache is divided into layers. You have like the very fast the most efficient cache is L1 cache, you got the L2 cache, and you got the L3 cache, and basically this will hold small data but it works faster. This holds more data but it's slower. This holds more data and it's even slower. So this is like the cache system, how it works. But yeah, it's different from registers. It's just another type of memory. Okay. What else? So yeah, now we will take a look at debugging. So we will try debugging our own program that we have made. And also this is actually a good way to learn assembly too. If you are new to assembly, debugging your own programs is a good way to learn assembly. Also there is a website called Compilation, I think. Compilation.io. I will send the link in the chat. Compilation.io it's a CTF-like concept, but instead of reverse engineering the programs, you actually have to. Okay, I need to make an account. But yeah, instead of reverse engineering the programs, you need to. He will give you, I think, the assembly. This is what I remember. This is the interface. You got the assembly here, and in here you got some code editor, and you need to write C code or C++ code or Python code that, when compiled, will match the same assembly. This is what the website is about. It's a good way to actually learn assembly too, and the reverse engineering is also good for it. Okay, and also if you look at the scoreboard. Like we got CTF teams actually at the top of the scoreboard, so yeah, I encourage you to play. Cache is the fastest memory, sort of speak, which is used to hold necessary data that the CPU needs to access in a fast manner. Well, sort of. Yes, that's a good explanation. Okay. So, if you are using GDB for the first time, you will actually not get this colorful kind of screen. So, what you need to do is, I'm using Pwning. You just have to install a plugin. A plugin here will help you. It's a GDB plugin, so it will actually customize GDB. It will make it more colorful. And it will contain more commands that are very helpful in binary exploitation and reverse engineering. So I'm using Pwning for a long time, and I'm very satisfied with it. There is also a very good plugin called Jeff or Gef or whatever you'd like to call it. It's also a good plugin. I don't know. I see a lot of top players using Gef or Jeff instead of PwngDBG, but also PwngDBG is made by CTF players for the CTF players and for other purposes like bug bounty. So both of them are really good. You just pick one and stick to it. And the installation is very simple. They already got steps there, like they defined the steps there. Okay, just a second. Okay. So yeah, if you like to see the defined functions using the debugger, you could just type info func ginmo use pwngdebug. We got. Okay, info func is a GDB command that will give you the defined functions. And sorry, bro, I am disturbing you, but what are you teaching in? What are you teaching in bug bounty? Sorry, I didn't understand the question. Is it when are you teaching bug bounty or what? Just reformulate it. I'm happy to answer it. Okay, this is the main function. If you'd like to disassemble it, like get the assembly, you could just run the disassemble command, but you are very lazy to type all these characters, so you could just type in an abbreviation of the command and it will run the same command for you. It needs another S because there is another command with the same start. So yeah, this is the assembly for our simple function. Okay, let me get I will zoom out a little bit and I will open the program again. How do I open it in reading mode? This is it. So this is the C program, this is assembly. Okay, I'm not gonna talk about these for the moment. I will talk about them in a little while. And this is actually the real part, I would say. Okay, so this will run the return 0, and these 3 lines are running the puts with the hello world. Okay, so you got a register called RIP. So forget about the R. The R is just like it's just used to tell that this is a register used for 64-bit architectures. It's not a 32-bit like architecture register or anything. And then you got the IP, and what IP means instruction pointer. Okay, and this is a really important concept. So you see, this is the assembly code, and there is an address for each instruction here. So each instruction contains an address. Okay, these addresses are just memory addresses that will point on where the instruction machine code is put into the RAM, like I would say, into memory. And so the instruction pointer, this register, contains always the address for the currently being executed instruction. So it points on the instruction that we are currently executing. This is what RIP does. And what's happening here in this line, it's called dynamic, it's like not dynamic addressing, wait. I'm forgetting lots of names. Okay, I think it's called dynamic, not round, dynamic. I think it's dynamic addressing. Okay, why it's called dynamic addressing? Because it doesn't put the address of the hello world string. It didn't put the address for the hello world string. It actually resolved the address dynamically during runtime. So during runtime, it actually took the RIP. The RIP is pointing on this instruction, on this address, and then it added a constant to the RIP, which is this constant, and with the result of this addition is just an address pointing on the hello world string. Sorry for disturbing this session. Enjoy this session. No, you're not actually disturbing me. I'm happy to answer the questions, but I just didn't understand the question quite well. This is it. Okay. This is the instruction pointer. This is what it does. This is dynamic addressing. This is how you resolve addresses during runtime. And yeah, then it saved the address in the RIX register. Then it moved the content of RIX into the RDI register. And I will tell you why it did that. It's not just losing instructions. RIP is used for dynamic addressing. Yeah. Isn't trip for next instruction. No, it's for the current instruction, I think. Okay, and what else? So yeah, why did he actually move RAX into RDI? Why did he do that? And then after moving it into RDI, he called the puts function. Basically, in the we have a blackboard. So in the 64-bit architectures, in like I'm talking about AMD/Intel. These two architectures. Okay, so yeah, how do you pass parameters? So when you call a function with 1, 2, 3, like three arguments, how are arguments passed to the function? So in 64-bit mode, the arguments are passed in through registers. So the first argument is passed through the RDI register, and this is why he moved the RAX into RDI. This is why, because the RDI should always contain a pointer to the first argument, or like the first argument itself. Then the second argument is passed through the RSI register, and the third argument is passed through the RDX register. So this is it, and there are more registers for more arguments, but I'm not going to talk about them. Yeah, this is why he passed RAX into RDI, just to pass the pointer of the hello world string into RDI for the first argument of puts. This is basic assembly. This is basic knowledge in assembly that you need to have, because sometimes you're not going to read the CD compilation in order to exploit the program. You're going to read the assembly and try to figure out the bug from there, because C sometimes is more general than you need, and it will just make you lose the path sometimes. So yeah, okay, and I'm not going to talk about these ones. I will talk about them in a second. Internal pointer. Okay, if I try to debug it though, if I try to debug it, I will use the B. B is basically breakpoint. So I'm setting a breakpoint, and the star is used to tell that it's an address. So if I make a star main, this will break at the start of the main. So it set a breakpoint at this address. This address is basically just the first instruction of the main function. Okay. So if now I run the program, let me close the other tab. Okay, this is the interface that we got. This is the interface that GDB and Pwn debug gave. You got here the different registers. These are registers here, and you got the content of these registers. So RAX holds this thing, and RBX holds this thing, and so on and so forth. What do you mean by a breakpoint? A breakpoint is basically where do you want to stop the execution on. So if I like to, let me delete the breakpoint. Let me disassemble main again. This is the main function. If I wanted to skip all of this code, I don't want to debug this code. I want to skip this code, and I want to start debugging, like even this. I want to start debugging here. I want to start debugging from this instruction. I will just use a breakpoint onto that instruction. I will just breakpoint when the execution reaches that instruction. So I do B and I put the address and run again, and you see we are currently executing this instruction. It's what's its purpose? I mean, you need to set a breakpoint in order to start debugging. That's like, you need to do it. And a more specific purpose would be like, I mean, if you want to skip a part of the code, you just set a breakpoint at the place you want to. If you want to jump between blocks of code, you set 2 breakpoints between these 2 blocks of code. Okay. Next. So yeah, and you could look here, the RDI, which will contain the first argument, actually contains an address pointing onto the hello world string. So yeah, as we said, RDI contains our first argument here. And if I want to, you want to examine things there. Okay, yeah. Let's say in GDB you got an address, and you want to see the content of that address. So what does it hold? You just copy the address, and you could do the X command. The X command is like examine slash, and if I wanted to do JX is basically, it will output like big bytes. It will just give you 8 bytes. You will see it. You have the WX. Sometimes you need to view the content of registers at time X, or you may want to see how the program flow is dealing with something. That's when you want to breakpoint. Okay. Or you might want to use the WX. WX is for 4 bytes. You have BX for 1 byte. Just if you want to output 1 byte. you'll see it. So JX and the address. You could either do that, you could put the address, or you could put the register that is holding the address. So you could do $RGI. This will also access the memory RGI is pointing to. And you see here you have the bytes. You just got the bytes from the hello world string, and this is a little weird if you are new to this. Why? Because we have. Let me just get another terminal with Python. So we have hello world, right? This is the string that we got. If I try to convert each character of this string to hexadecimal, hex word, yeah, this is the hex. This is the H character. This is the E character, this is the L character, this is, and so on and so forth. Basically, the problem in here that this is the H, so it was inversed. Linus Gibbs. So it was inversed. The H is here, and you got the E here, you got the L here, you got the L here, and so on. So why did the bytes of the hello world string got inversed? So this is actually a question. And the basic answer for it is that there are two ways to store things in memory, and you could also call them just like you could call them as encodings. So you are encoding data in a certain format, and this way by reversing it. Basically, let's take the hello string. So the hello string got stored in memory in a reversed order. So it got stored in this way. This is how it was stored. And what this encoding is called, it's called little endian. All right. So my processor uses little endian. This is why the string got reverse order when being stored in memory. If you want to keep the bytes as they are in the same order they were initially, you will just use something called big endian. It's just an endianness. So little endian will reverse the bytes of the string, and big endian will just keep it. So big endian is the way you read English or any other language, and little endian is in the reverse order. This is used to confuse me a lot. I never understood why people store hex in different ways. Actually, storing hex in different ways is useful in some cases. Like the big endian got like it has its own advantages, and the little endian also has its own advantages. If you want to talk about little endian, I will just give you like the most famous advantage of using little endian. It's very useful, it's very efficient, it's very optimized if you are trying to like play with numbers. So if you are dealing with numbers, little endian is so good. Why? Because let's say you are adding two numbers here. All right, if you are adding two numbers, you are going to start the addition from right to the left, and this is how little endian helps. It will start doing it in the reverse order, so it will actually make the addition in a more efficient way. It will just start doing it from here and then here and then here. This is the most famous advantage. On the other hand, big endian got some advantages, but I would say big endian, the most advantage in big endian is just the way you read it. It's very simple when you are trying to read it. Does it depend on the architectures? Yes, it mainly depends on the architecture. Each architecture got its endianness. So Intel and AMD are using little endian here. Okay, and if you are asking why are we even learning little endian, it's actually very useful. Little endian is it's going to be useful along the way, because when you are trying to exploit a bug and you want to put stuff in memory, you actually need to know that it's using little endian, so you actually reverse the order of the bytes before putting it into memory. There is a big brag about that. I can send you a paper to understand how the thing started. Yes, sending the link would be useful for the community. Okay. So this is data landing. So until this point, we have discussed assembly, the L file format, the sections, how the compiler and disassemblers work, debugging. Okay, we have talked about most of the stuff, and I think now we will just try to exploit a program. We will make a vulnerable program, and then we will try to exploit it. And when exploiting the program, I will introduce you to the stack, which is a memory structure that functions use, that C and C++ functions use. And yeah, so let's start. Okay, this is the program. I will send the link in here, or in the Discord server. It would be helpful for everyone. You could actually make a channel in the Discord server for this live stream and just throw links that were discussed during the live stream. Okay, so back to the C program. So what I'm gonna do right now is I'm going to create a vulnerable program that is vulnerable to a kind of bug. I sent it or it got deleted. You didn't send anything. Nothing was sent. Okay. Send it on Discord, yes. So I will make a vulnerable program to some kind of bug called buffer overflow. Okay, so let me talk a little bit about buffer overflow though. So let's say you got, what's the timing of live stream? Live streams are always from 7 p.m. From 6 p.m. in UTC. 6 p.m. UTC always. But sometimes I do it on like Thursday or a Tuesday or a Friday. These are the main days. Sometimes on a Saturday. But yeah, my schedule is actually bad for the next 2 weeks, so I might just throw live streams out of nowhere. So it might be a Wednesday, a Monday. You don't know. That's the problem. It's just a bad schedule. Okay, so let's say you got some program that is taking input. So I'm just defining a function called taking input from user. This function is called. We have some string here. I'm just writing pseudocode. It's not C. It's not C++. It's just a pseudocode to explain stuff. So let's say this is the function taking input from user, and it will take input from user and store it in the X memory. X is a string, so you know what a string is this, like this is a string. Okay. So the string X is stored in memory. So let me draw a memory here. Let's say this is memory. Okay. Okay. So this is memory, and let me say too, I'm just going to say here that the X has a size of 10 bytes. So X could only hold 10 bytes. That's the maximum. And we are reading bytes into X. And there is another string just under it, which also can only hold 10 bytes, right? So we are reading from X. Let me just draw the second memory. So this will be Y, and this will be X. Okay. So you are reading into X. You will read bytes into X. You got the Y string. Let's say I'm going to also initialize it to A, B, C, D. I would say. So here you got A, B, C, D. And you are reading into the X. So let's say instead of inputting inputting 10 bytes only, I want to input 20 bytes. I could do that. So instead of doing 10 bytes, I would input 10 bytes, 20 bytes. So if I input 20 bytes, what would happen exactly? So you got the 10 bytes here. This is your input. You have inputted 10 bytes. Then the 11th character, the 11th byte that you input, will overflow from the X memory case into the Y string, and it will overwrite the A character. So let's say the 11th character is a D or an E. An E which would be stored in the place of the A. So you overflowed from the X memory case to the Y memory case, and you started overwriting data in the Y memory case too. This is called a buffer overflow. So you have overflowed from a buffer, and you started overwriting stuff or writing stuff to other buffers and other places in memory. So this is the bug. It's a pretty simple type of bug, and we are going to focus on doing it here and exploiting it. And I will talk about what could you actually gain from exploiting a buffer overflow. So how could a buffer overflow help me? Sorry, are you work for a company or an entrepreneur? I'm actually still a student, so no, I'm not working for neither of them. Okay, so let me define the string that we talked about. This is the X string. In C, the way you define strings is through arrays. A string in C is basically an array of characters. An array is also just like a table of characters, I'd say. So let me define 10 here. I'm going to give it 10. And I'm going to use a function that is a famous function called gets. Okay, this gets function will just get input from keyboard. This is all what it will do. Okay, and also a good thing I would encourage most people to do is when you encounter a function and you want to know what does this function do. So like you have encountered a function that you don't know about it, you don't know what it does. The best thing to do is to use the Linux manual. It's not always the best case, but like it's really helpful. It's very detailed, so use it. For example, let's say I don't know what the gets function is doing. I will use man, which is the manual command, and gets. This is not from the C manual page, so I'm going to skip another section, and I'm going to skip another section, and in the third section, the gets C function is defined. So you will see the description of it. So it will tell you that it will read a line from standard input into the buffer pointed to by the S. The S is the argument used in here. So it will tell you how it works, and it will also tell you the return value. So like what should the gets function return? So on success, it will return a pointer to the string you are reading into. Otherwise, it will return an error or null or whatever. Okay. This is a good way to actually know how functions work. And I could do like a printf here, enter something, for example. I would say this is just a message for the user. And let me compile my program now. gcc buff.c. Okay, it didn't want to compile it. Or, oh no, wait. Is it removed in the new glibc? I think it's removed. I think it's deprecated. It's deprecated, but I think it's removed. Am I sure it's removed? Probably removed because like it couldn't actually resolve it, and it's in the standard input output, I'm sure. So yeah. But anyways, let me use another function. It's not the end of the world here. I will use the fgets function. Fgets function is the secure version of the gets function. So fgets. This is it. To read, and why is it secure? Because fgets will have a limited size. This is why. Because you could just limit the size of the input, and this way you could secure against buffer overflows. and then it takes like a file, which is basically the file descriptor, like a structure. So first of all, the first argument is the string you are reading into, so x. The second argument is just the size. I'm going to read 5 bytes only. And the third argument is where you are trying to get things from. I'm trying to get things from stdin, which is the standard input, which is just my keyboard here. And I will compile it again. I will remove this for the moment. I will talk about it later. And yeah, this is a program. If I execute it, enter something, I enter something, and this is it. We could add some more stuff. We could say that x is equal to something right now. We could show x like before. Yeah. We could show the content of the x after we input something. I need to recompile. And yeah, you see, it only takes 5 bytes, and these are the 5 bytes it has took, right? And it stored them into x. So this is pretty secure. It's not vulnerable to buffer overflows. Why? Because you are just reading 5 bytes into 10 bytes. So like you are just in the half. You haven't overflowed. You didn't reach the end of the allocated space for that variable. So it's not a buffer overflow. However, if I change that 5 to something bigger, let's say the 10, or like even 13 or whatever. Okay, here the compiler is trying to warn you that there exists a buffer overflow, but we're going to ignore it and enter something, and you see a stack smashing detected message. This is because we have overwritten stuff in memory that our program used later, and so it used it in a wrong way, and this way like it ended execution. It's a stack smashing detected. Okay, the stack, also the word stack. The stack is basically a memory. It's just a memory structure. And the stack is the memory that functions will use in C and C++ like programs. So if I try to, or let's take a look at like memory structures OS. I don't know if that will give me. Oh, this is program process. This is not bad though. There is like a scheme that I was using back in the days to showcase how things work, but I don't seem to find. Okay, here it is. This is better. Okay, so this is the, let's say this is the memory. This is the RAM you got on your computer. So you have here. You have some stuff here. He called it command line arguments and environment variables, but ignore it for the moment. You have the stack used by your current process, your current program. You have the heap, and you have the other sections that we have talked about, the data and the BSS, and you have the text section which will contain the code. So the stack is a memory, is part of the memory that the program will use, and it's used to store data of functions. It's only reserved for functions, like. That's why when you like initialize a global variable, it's not put into the stack. It's put into another section called the BSS or the data section, depending on how you declared it. So yeah, stack is just the memory that are used for functions. What is stored inside the stack are basically the local variables. So when a variable is declared or initialized inside of a function, it's called the local variable. It's local to the function. And the stack, for example, the stack of the main program will just contain the x variable. It will just contain reserved allocated memory from the stack for the x variable, for the content of the x variable. And we're going to see it through a debugger, because debugger will give you access to the memory, and so you could see stuff. I will break at the main function again, and what happens if stack and heap coincidence? This will never happen. This will never happen, sadly. I know in the memory layout it's they appear to be next to each other, but this will never happen. Also, just for your information, the layout you see in here is not real. It's just a theoretical layout. This is virtual space, and virtual space and physical space differ. It's actually a concept that you guys need to know. You could Google about it. Virtual address mapping, I would say. I'm just going to try give a small explanation. You could see. Okay, you see, this is the program. This is our program. This is the memory for our program. You see the virtual memory here is the language you are using, C++ or C. I'm using C programming language, not C++. The virtual memory. So you see the different sections in a theoretical point of view. If you are viewing it in the virtual memory, they will appear to be next to each other. However, in reality, they are actually separated into the physical memory. So this is the RAM. Here you got the RAM, and each section, not each section, but each page. It's called a page or a segment. So each page, a page is basically like a block of data. And in modern systems, a page is, if I remember correctly, it's 4 kilobytes of space. So for each page in memory will contain 4 kilobytes. This is the RAM, and then the operating system will distribute the different pages into the physical memory. And so they first of all they cannot have a coincidence. And the second thing that you need to know is this is the stack. Look at one address from the stack. It's actually a very big address. Now I'm not sure if my program is going to use the heap here. Okay, it didn't actually reserve stuff for the heap. Also, for those who don't know, the heap is just another memory structure. It's another memory place, and what differs from stack and heap is basically that heap is dynamic. Heap is used for dynamic allocation. When you are programming in C, the size of your variables is already declared. If you are going to make an array of integers, you say that you will tell C that your array will contain 5 elements or X elements or whatever, and you cannot change that size. This is the problem. This is the problem with the stack. The memory is already fixed. You cannot change it. However, when you are dealing with heap is dynamically allocated memory. You could actually change size. You could allocate a 50 byte chunk into the heap, and then you could reallocate it to contain 60 bytes or 100 bytes or whatever. So you could just play with bytes in the heap. That's never been a problem. Okay, where did you learn hacking, and if I want to get started, what do you suggest? Okay, I actually learned it the hard way, and what I mean by the hard way, it was a very tough start. I just started as a script kiddie, just like the majority of the people did, and I was just using tools like a script kiddie. I don't know what the tools does, but I just use it, and I call myself a hacker, and then at some point I needed to learn programming, so I started learning some programming. I started with the Python language. That was let me tell. It was about 7 years ago, I think. Yeah, 7 years ago I have done I've started to learn programming, and then after learning programming, a year have passed, and then I got to know CTFs. I know what CTFs are after a year. So I started competing in CTF competitions, and I started as a noob. I didn't know what binary exploitation is. I didn't know how the computer worked. I didn't know anything, but I just started as a noob. I competed alone. I didn't have a team too. I started competing alone in the competitions. It happens that I enter into a competition and I don't solve any of the challenges. So I just enter and quit normally. And then I look at the write-ups, and the write-ups were actually helpful. Write-ups are the main resource that made me learn like computer science and even like the programming skills and the hacking skills also. And I started learning from write-ups. When I don't understand something, I will just switch. Like if the write-up contained the word assembly, I didn't know what assembly is, I will just go and Google about assembly, see what assembly is. Is it really helpful to learn it at this point? If yes, I will go to learn it. If no, I will get back to the write-up. I know what assembly is, but I don't know how to program in it. But I could like read the write-up and complete reading it and understand it. Yeah, I started also, and then I started doing bug bounty hunting for fun, never for profit because I didn't have the skills at the time. I also a good resource. Let me just give you guys a very good resource to learn from. It's actually the Gimvale channel. Sorry for. Okay, it's actually the Gimvale channel. Gimvale is an old hacker. He was the tech leader for the security team in Google. Now he's running his own startup. He started doing the live streams in a very old time, and the main live streams that helped me were the Pico CTF's live streams. So I would just like watch all of them at the time, because Pico CTF, as you know, contains beginner friendly challenges. And yeah, Gimvale is actually well with explaining the different challenges and like how he also explains how computers work and how to do programming in the right way. He got a lot of live streams, like many technical live streams. He even got a live for how to approach competitions. He talks about how to approach competitions, like if it is a competitive programming or whatever. Yeah, Gimvale is low key. You need to watch Gimvale. He's so good. It was one of the main resources I was learning from. So yeah, thank you so much for the content. I really love your channel and see you as inspiration for my future self. That actually means a lot. I mean, I'm not that good to be considered as an inspiration, but yeah, I will finish bachelor on informatics this year, and I want to get into cybersecurity as masters. Do you suggest it to me? It actually depends on what you will learn during the master's degree, during those years, because like for me and for many other people, it's actually like attending or learning cybersecurity from a university is not the best thing. It's just for me. It's my point of view. I might be wrong, you know. But what I see computer like cybersecurity is, I see it as a hobby before everything. And there are actually very complex stuff that they are not teaching in universities. It's like how computers work in details. They actually don't teach that. They will just give you like a general, an abstract view of how computers work, and this is it. Yeah, as he said, do whatever you want. 90% will be taught at home. Yeah, you will be the teacher of yourself. You need to learn stuff yourself. The resources are everywhere. You just also if you know people that are better than you, then yeah, you need to ask them for help if like you got questions and everything. It is a double system in AI and in ethical hacking. Yeah, but I still don't know what will be the content of the courses you will take. But yeah, even I mean, it's not a bad thing to have the master's degree. That's an advantage if you are going to work at, if you are willing to work at a good company next. But yeah, as I said, it's actually the hard stuff you will learn by yourself. Most of the stuff you will learn just by yourself, by sitting at the computer and trying stuff and like having errors thrown at your screen all day and trying to fix them. You will learn that way. This is the right way to learn stuff. Yeah, as I always say, it's also like a Geo Hot saying, like a George Hotz. You know this guy. You know George Hotz, guys. I don't have to talk about George Hotz. He's a very old hacker, very talented hacker. He was the first to jailbreak the iPhone and everything. So, you know, George Hotz always complains about this stuff, about being a noob. I will actually send a YouTube video about it. Just a second. George Hotz, stop being a noob, I think. I think this is the video, I don't know. This is the longer video, but yeah, you need to watch it. You need to watch it. After watching it, you will actually understand.
I'll tell you. Here's the simplest definition.
So yeah, don't be a noob, and don't be a noob is just you need to do the stuff yourself. You will never learn how to program or how to hack from watching a YouTube video or like from taking a course on Udemy or whatever. You will learn these things by doing it yourself and by failing at it millions of times and by then figuring out the solution. This way you will learn. This is like the best way to learn things. And yeah, I guarantee it because I have passed through that. Every good hacker, every good person at what he's doing have actually done that before, and he knows it. So you need to do stuff by your own. When you understand how things work, then you can hack. So yeah, you need to understand how computers work. That's the most important thing. It will help a lot. Yeah, I remember like the year I learned assembly. I just felt like my brain stretched, you know. I felt like I was smarter because, you know, learning assembly will make you learn how computers are working and how they are dealing with memory and how they are performing different operations and everything. Like, what is the computer capable of doing? And knowing that actually helped me in other different categories, like along the way. It helps a lot. You need to do it. Yeah, you need to learn C and assembly for sure. Like, you need that. What's your dream in this field? My dream in this field. Okay, actually, I don't know. Maybe my dream is one day owning like a research laboratory for binary exploitation, pwning, and like these stuff, malware analysis. I just want to start having like a company in the field. That making it a big company is also a dream. So yeah, I also want to work with people that are way better than me at different laboratories, just like, I don't know, Star Labs or those ones. I really appreciate your explanation so far, and thank you so much for being so helpful to me. Yeah, no problem. That's what I should do. What's your dream? That's already answered. Are the certificates important for having a job in the field of cybersecurity, especially as a SOC analyst? If yes, what do you suggest? Thank you. Okay, a lot of people will hate on me on saying that, but yeah, it loves. But yeah, I don't know. I don't see certifications like a big deal, and this is also my point of view. But yeah, companies, especially like medium companies, will require some certifications for you to enter or to get the job. So if you are trying to like build a career and start working with a small company or like a medium-sized company, stuff like that, I would say certifications would be helpful. But I don't know, like big companies like Google would not actually complain about you not having an SCP or whatever to get the job. Like, they are looking for skills instead of validation. Like, taking a certificate is just a validation. Like, somebody validated that you own the knowledge for that certification that you got. However, big companies are looking for skill, and skill is not gathered through validation. You get skill by hard working and by making your own projects and, you know, hacking your own stuff like that. But yeah, as I said, I hope I have answered the question. The modesty that you have is a virtue that not many people have, and I just want to compliment you for it. Thank you so much. That means a lot. You definitely achieve your goal. I hope so. Is it worth paying for a hack course? No, never. It's not worth it at all to pay for a hacking course because information is just public. I don't know. You want to learn binary exploitation? You just okay. I'm sorry for opening that again. You want to get like a binary exploitation? Learn it. You just head to Pwning College. Pwning College is a good resource. This is Pwning College. Also, like buying a hacking course. I don't know. It's not worth it. You first of all, you don't know the person that is delivering the course, so it might not be the high quality you expect. It might not contain the useful information you expect. So yeah, it's not worth it. Googling, watching like good people in the field do the stuff on YouTube is good, and we will get you through the road. But Pwning College is really good though for binary exploitation. But yeah, if you win a voucher, why not? But yeah, that's still not like a good thing. I don't know. I don't see it as a good thing. I don't like paying for hacking course. Not even hacking course. Even programming courses or anything. I don't want to pay for them. Because I know information is public, and I know that the right way to learn stuff is not just by watching people do it. Is you need to try the things yourself, and you need to just like explore the world by yourself. I didn't have the possibility to follow you from the start. Can you maybe explain again briefly what were you hacking? I was making a little vulnerable program to BufferOverflow, and then I will try to exploit it using Python. So yeah, but we stopped for asking some questions. Just view certs as HR bypass. That's it. And certification market is a thing beyond the simple certification. It's a new system, and we need to accept it. Yeah, that's a sad reality. It's a new system, but yeah, you still got other doors open for you. So I don't know. Like if you let me show you another thing. I think this. So this is the Q&A of Ginveil. If you like to read it yourself, I will just paste it to the screen. Okay, so you see. Somebody have asked Ginveil about the certifications that he got, and this is his answer. I don't have any certificates, and in my particular field, I don't feel the need to have any. And this is because he's talking about his own experience. So yeah, who is that man in the photo? Aziz. So yeah. And also, it's each person like got his own point of view, but this is like I don't know. I don't want to accept it because yeah, as I said, there are open doors. It's not certifications are not the only way to get a good job. You could get better jobs, and like without having any certifications. So yeah. Let me also send his channel. Pwning College channel. And yeah, is that Mr. Fushika? Yes. Are you currently working on your field? Not really. I have done only one internship. And yeah, I just have never worked. Sometimes like freelancing jobs, and yeah, that's it. Or otherwise I will do just bug bounty. I will do bug bounty, but I'm not very consistent with it. I sometimes stop doing it, and then after a long time I get back to bug bounties and everything. So, what is his role in the company of Google? Yeah, okay, I will give it to you from here. I don't want to answer that because I might answer it in a wrong way. So, yeah, he was working as the technical lead manager in a security engineering team. In Google there are many security engineering teams, and Gimvale was like the tech leader of one of them, the manager of one of them. So yeah. How much do freelancing jobs or bug bounty get paid? Freelancing jobs pay well if you are offering services that are not offered by everybody, and also if you are doing the job in an efficient way. You need to do the job in the best you can, so that the client is satisfied, and the client will also come back to you, like offering another job. So freelancing is a good way to get money in the field, I would say. Like, you could just go to Upwork and search for the jobs. You'd find hundreds of people asking for pen testing their website, or like I don't know, helping with reverse engineering something, developing an Android app. So like there are many jobs. For the bug bounty part, I don't know, maybe I'm lucky with bug bounty, but I actually got paid well on bug bounties, on the bounties I found. And Gimvale, as a technical lead at Google, has a full HTML page. It's enabled. I enabled the tip notification already. I have enabled it. Yeah, as I was saying, maybe I'm lucky, I don't know. I got paid very well. I found 2 bugs on Epic Games bug bounty program, and I found a bug on a VPN. Okay, it was CyberGhost VPN. I found a way to leak the original IP of the client, bypassing the functionalities of the VPN, and I got paid well. So yeah, but I'm just not consistent. I'm not doing it all the time. This is why I'm not gaining lots of money from it. But yeah, when I want to do it, I'm sure I will find more bugs, and yeah, it's also a good way. There is like that YouTube channel called Bug Bounties. I think Bug Bounty Explained. I'm not sure. Let me see. Yeah, BBRE. This guy was working as a pen tester, and then he quit his job. He quit his job for being a full-time bug bounty hunter. There is a video where he talks about his journey, and he got lots of money from the beginning, actually. So yeah, he made quite a good amount of money. So yeah, do watch his live streams. He's so good. There is also many people that made so much money. Can you give us an exact sum? Like, is it his money or my money? For my money, it's not that much. Like maybe $1,000 and something. That's it. Like, because yeah, I haven't worked for much. I just didn't work for that much. Yeah, I said like $1,000. I work on HackerOne and Bugcrowd and Integrity. These are the 3 platforms I do bug bounty on. So yeah, I hope I answered your questions very well. If there are no more questions, we can get back to the live stream. We might do another live stream about like Q&As. That would be fun, I think. Right. That's good compared to the difficulty. The difficulty. Okay, I actually like to say that CTF competitions, challenges are harder than real life in most of the cases. Not all of them, but most of the cases. Because CTF competitions offer, like, I'm talking about the web category only, because this is what we do bug bounty on. You could do bug bounty on like low-level programs. That's also a thing. But yeah, talking about the web category, CTF competitions are harder than real life in most cases, because the scenarios are somewhat sophisticated and complex, you know. So yeah, and yeah, I didn't actually spend that much time to find my first bug too. So yeah, it was just over a night, and it was luck. It wasn't skill, it was just luck for finding my first bug. But yeah, if you like, bug bounty is also about the reconnaissance. If you know what you are doing with the reconnaissance part, then you will get like better results. And you know, when you get the results, you could just get the different endpoints that you think they are vulnerable, and then like you could just put each endpoint as a CTF challenge, right? You could just make it that small until it's a CTF challenge. Chinese CTFs go brr. Yeah, true. Chinese CTFs are hard. Also, Sekai CTF has ended 25th. We do have good web challenges if you want to play, so yeah, take a look. I think we also got like a challenge that is still let me see. This challenge, Sekai licensing, is 0 solves. If anyone solves it, he will get a $100 bounty. So you could, when you solve it, you could just throw your explanation at the Discord server. We got the Discord server here. So yeah, I don't think anyone has solved it yet. So yeah, maybe take a chance. You don't know. You don't know. Right. I think we can go back. كان عندك certificate okay. Okay, also join the Discord server, everyone. Just if one of the mods just throws an invitation link on the chat. Okay, back to what we were doing. The custom AES was a bit of C. Are you talking shit about my challenge like this one? I mean, it was mostly assembly, not C. Discord, please. معتز بربي تشيري لينك. خرجنا على الموضوع، يجي يخدم في بلاستي حول الله. ده let's get back. Okay, as you could see, as I said, let me put you again in the context. We initialized the variable that contained 10 bytes only. Good night, bro. Good night. Have a good night. And we were trying to read 13 bytes into the 10 bytes. Good task though. Yeah, thank you. I made it, I think, in 2 hours or something. So yeah, I didn't actually put that much effort onto the challenge. Okay. And we are trying to read 13 bytes into 13 bytes into 10 bytes. So there are 3 extra bytes that we are trying to read. Okay, and when we put more than 10 bytes, a message appeared saying stack smashing detected, and the program was terminated. It didn't execute normally. That's a big problem. So let's see it with a debugger. I would like to have a bigger view of the debugger. So main function, and okay, I think we compiled again, so the assembly changed. This is the new main function, printf fgets. I'm going to set a breakpoint on the fgets function because it's where we are giving input, so that's a good point to break on. And yeah, it's being called, and you could see the different arguments either by looking here, or as we said, first argument is RDI, second argument is RSI, third argument is RGX. You could see it's a pointer to the stdin, and this is the size. 0xd is just 13 bytes, and this is the address into the stack, the memory that we are putting the storing input into. So if I copy this address, if I do NE is just next instruction, so I'm just executing this instruction and passing into the next instruction. Enter something. Okay, let's say AAA, BBB, CCC, ABD. Okay, you could now see the stack. This is the stack. You can see it's the stack. This is where our input was copied, you see? And there was a big problem here. There was some data. This is not my data, this is not the data. And this data was overwritten. Was overwritten by the CC here. It's a DD, not, wait. Oh yeah, it's, wait, maybe I am wrong with something. No, I don't think I was wrong. It's I did enter a D or not, I don't remember. Oh yeah, I did enter some D's, so oh yeah, that was bigger than 13 bytes. I'm sorry, so it only copied 8 bytes. These are 8 bytes and these are 2 bytes. You see, and those 2 bytes overflowed into another memory that contained some useful functions. So some useful data that the program is working with, and this is why like it throw some error. It couldn't really execute with this data being corrupted or clobbered with. Yeah, I'm going to make it more simple, so I'm going to initialize an x, sorry, x is already initialized, a y variable. This is just an integer, and it will contain the like 0x, I would say 1245. Okay, this is an integer. Now let me compile it again and run again. I need to do it again, I think. Okay, let me break at main plus 69. This is it. So again, we are reading here. We are reading into the 23E. 23E, sadly, is, let me show you something here. Okay, you could see this is the integer. This is the integer. It's at address 38, and this is where our data should be stored, and it's after the integer. So like this, if this was memory, you have the integer here and you have the data here, so you actually cannot overflow it because you are putting data after it, so you cannot really overflow into the integer. That's a big problem. And why did this happen even after me putting the integer under the array of characters? Basically, this is like a security in the compiler itself. It's trying to put variables that we have control over, just like the x variable. We could control it. It's putting it just like at the end of the stack, and putting other variables above it, so we do not clobber the data of these variables. And it's just a security in the compiler. And I can actually disable this security. As you could see, this is AA, the data I have inputted, and this is the integer, and we cannot overflow it. So let me show you how to disable the security. So there's like an option in the GCC compiler called fnostack_protector. This will disable protection on the stack, and the variables will keep the order that you define them in. So now if I run the program again, it's at 54. Yeah, if I run it again, we are taking input into the E242. Yeah, that's good. That's very good. So you see, we are trying to put data here, and look at the integer. The integer is here. So we could just input 4 bytes, another 4 bytes, and then the 9th byte will overflow into the integer. And you could try this. You could try it. So let's say I would enter here 4 A's, 4 B's, and then some C's. Okay, 3 C's, I would say. So let me enter AAA, BBB, and then 3 C's here, and let's take a look at the memory again. As you could see, the integer was here, and we have overflowed it. You see, these are 8 bytes, and these are 2 bytes. This is the 10 bytes of our x variable, and then there is the integer here. You see, and so we overflowed into the integer. Now, if I take the same input, let me just take the same input. I'm gonna paste it here, and I'm going to make another print statement that will show it will show the y variable, right? Oh, let me show you. Let me take the same input again, paste it here. You see, this is the new value of the integer. You could just convert it to hex and compare it to the old one. You see, this is the new value of it, 0A43, and this is the old value, 1234. So we have overflowed it. The 43 is the C character, and the 0A is just a new line. It's just the enter, it's the new line. So this way we have overflowed from the X case of memory into another case of memory that contained an integer, and we have overwritten the value of the integer. I hope this was like easy to understand. This is it. This is a buffer overflow, and the buffer overflow, you could do more and more of good stuff with the buffer overflow. Like yeah, there are many good things you could do with the buffer overflow, but I cannot actually talk about them right now. We have already passed in 2 hours into the live stream, and this will be a heavy one, so no, I'm not going to talk about it. But I will talk about it until the next live stream in this series, in the binary exploitation series. Yeah. So I hope this was okay. I hope this was helpful. I hope we have discussed some stuff in this live stream. I'm feeling headaches right now, so I'm thinking of actually cutting the stream, and I will see you on the next one. I'm so sorry, I have so much work. This is why I'm actually a little busy, and this is why I'm a little busy and a little, you know, a little tired. I'm so much tired, actually. So if you don't know, in 2 weeks or 3 weeks, we have where is the CTF? We have the security nets. Please work. The security nets CTF calls. It's a high quality CTF. It's a high quality CTF. It will. I'm not sure if it's beginner friendly though. I don't know. But it's a good CTF if you are planning to participate. You will actually learn a lot from the CTF. It's a good one. We have pretty much all categories, from web to Pwn to crypto to reverse engineering to forensics to MISC to, I think that's it. Yeah, and top 3 Tunisian teams are qualified and top 15 teams are qualified, and they are welcome to visit Tunisia to play the finals. So I'm sorry again for ending the stream early. I had more stuff to talk about, but I'm actually feeling so tired, so I'm sorry again. Yeah, شنو هي بوا هيك 95 waiting rating. Yeah, it's a very old CTF. This is why it holds a great weight. You know, it started in 2015, so yeah, it's an old CTF. This is why. So everyone is welcome. Okay, part 2. Part 2 is going to be, I don't know actually. I'm really sorry, because yeah, I need to finish writing challenges for the CTF, for the security net CTF, and it's hard. It's actually hard to inspire and to be creative to write a very hard challenge. So this is why it's time consuming and it's really tiring. I'm not sure if I'm going to make Sekai this year is 200. I'm not sure if I'm going to make a live stream for the next week. I'm not sure, but if I didn't, expect me on like I don't know, on 15th of September or something like that. Expect me on a Sunday. It's a Sunday, so yeah, 15th September maybe. If I didn't stream next week, I will get back on the 15th of September. I just need some rest and I need to complete the work I got. That's it. But yeah, trust me, when I get back after resting, I will like deliver high quality live streams. Like it will be so good. So yeah, I hope you enjoyed this one, guys. We had a great talk in the middle of the live stream. Yeah, I actually had fun on this one. This weekend Black Hat 2. مساندة المولد. Okay, if you enjoyed this live stream, don't forget to subscribe, give us a like, and yeah, don't forget to also join the Discord server. If you scroll up the chat, you will find the link. And yeah, guys, thanks for sticking to the end with me. I'm really glad to have you with me for this night. And yeah, again, if you need something, if you need help with something, if you got questions, you could just pass them on my Facebook or Discord. I will answer all DMs. If you want to find my links, you could just enter the channel and you could find them in the about section. You could find my Facebook, Twitter, or Instagram, and yeah, you could find my Discord too from the Discord server. So yeah, just I will thank you again for sticking. Thanks for all this amount of likes, so many likes. Thank you for the 260 subscribers. Thanks to everyone who shared, and special thanks to all moderators for sticking throughout the stream and for managing with me the Discord this morning. So yeah, thanks again for Matez. And yeah, I think this is the end. See you in 2 weeks maybe. I don't know. I will share on like LinkedIn and Facebook when I'm planning to do a live stream, so you might follow me there and you'll find out. Okay, so thanks again, guys. Thanks for all the donations during the streams. Love you so much.